Good afternoon and welcome everyone back from lunch to part 2 of the Uses of Geospatial Research and Data panel series. On Wednesday, we discussed how geospatial data helps climate change resiliency and urban planning. Today, we will discuss about urban mobility and social segregation. Let's meet the speakers. Joining us today is Lucas Shen, Research Affiliate, Asia Competitiveness Institute, Lee Kuan Yew School of Public Policy. And we have two speakers from the previous panel back with us, Apu Kumar, CEO of City Data, and Jeroen Borst, Program Manager of TNO. Welcome, gentlemen. We shall begin with a 10-minute presentation from each speaker to be followed by a panel discussion and Q&A. Audience, please feel free to pose your questions during the way. Lucas Shen from Lee Kuan Yew School of Public Policy will speak about segregation across neighborhoods of a small city. Lucas will highlight about the use of geospatial intelligence from City Data, one of the companies they are collaborating with, in his collaboration with them, and that can be used to detect social segregation in Singapore. Over to you, Lucas.
All right, so I share my slides. Okay, is everything working? You can see the slides.
Looks good.
You can hear me? Okay.
Yes.
All right. All right, so thanks, Vanessa, for moderating the panel. And also thanks to Apu and Yuliam from City Data for inviting me to join this panel with Apu himself and Jeroen from TNO. So I have 10 minutes to share some brief findings from a study that I did with my colleague Jingzi from the Asia Competitiveness Institute. So in this study, we combine geospatial data, which we got from City Data, with a range of other data sources to examine what is the impact of differences in neighborhood wealth levels on neighborhood visits. For a sense of scale, I'll cover the map of Singapore first. This is a map of Singapore with 5 census regions, which you can break down further into 55 census areas, which can be further broken down into more than 300 subzones. And then once we drop the subzones that do not have residential data, we end up with about 200 subzones, which for ease of exposition in this study, we call neighborhoods. Right? And I emphasize that our definition of neighborhoods is not necessarily the same as the government's definition of neighborhoods. And for a sense of scale, the neighborhoods on average are small. It's about 1 kilometer square or 0.4 square miles. So we are working with neighborhoods as our unit of analysis, which are small in scale, in a city that is small to begin with. And so I think this gives a sense of scale. Now we go into neighborhood wealth levels. And what we mean by neighborhood wealth levels is that we measure wealth levels using housing prices. So this map you see is the housing prices from house transaction records over the past 5 years. So this map plots out the locations of the transactions, and then the darker colors indicate higher prices. And this is how we measure neighborhood wealth levels, by matching the transaction records to the individual neighborhoods. And we do this because the next best thing is census income data, which is not available to us, at least at the neighborhood level. Right? It's only available at the more aggregated planning area level. But it's nonetheless a good measure because a simple check tells us that it's about a 0.9 correlation coefficient. So housing prices is a good measure of neighborhood wealth levels, and that's what we work with in this study. And then once we have neighborhood wealth levels, we can start answering the question, what is the effect of differences or mismatch in wealth levels on neighborhood visits. But first, we will talk about what we mean by mismatch of neighborhoods by wealth levels. And our definition is a very simple one. It's simply this. If we take a pair of neighborhoods, then we say that we have a mismatch if one of the neighborhoods is below the 25th percentile of wealth levels and the other one is above that cutoff. And it doesn't matter which order it occurs. So this is a mismatch, we call it. And once we have that, we can ask and examine what is the impact of mismatch by wealth on neighborhood visits on a real-time daily basis. And that's what we find. And this is what I mentioned at the beginning. If there is mismatch by wealth, then on average, there's going to be higher neighborhood visits on a daily basis, which in our study is what we call real-time exposure of individuals from different socio-economic background. But this effect is going to be asymmetric. And what we mean is that when we decompose that mismatch measure, we find that it's driven asymmetrically by people from the poorer neighborhood, which is P, visiting the wealthier neighborhoods, which is W. And that's what we see here in the bottom right corner. That was the picture at the beginning. And it's not driven at all by the opposite direction, where the individuals from the wealthier neighborhoods are going to the poorer neighborhoods. Right? And this will be the key takeaway, that we do see that if you have mismatch by wealth levels across neighborhoods, you would see higher exposure of individuals from those two different neighborhoods, but the exposure is going to be asymmetric. It's going to be driven by people from poorer neighborhoods visiting the wealthier neighborhoods. Right? That's what we find. And to my knowledge, it's not something that we have seen in other studies. And this is, just to remind the audience, this is the context of Singapore. Right? But I don't think that our concern is unique to the context of Singapore. Right? So I'll end. I have 3 minutes. So I'll show this slide. I came across this story this morning when I woke up, but it came out 2 days ago. So I'm late by 2 days. But this seems to have something to do with the topic that this talk that I'm giving today. So I put it here. There seems to be, so according to this story, there seems to be some kind of tension between the rich and the poor. And I thought that I could use this in this talk. And I think maybe it helps answer the question whether my study is a sensitive topic, which is a comment that I've gotten. But anyway, this is the Straits Times. This is the local national media here. So I think they cover it. So I can talk about it also. And like I mentioned just now, this issue of real-time experience segregation is not in any way unique to the context of Singapore. Right? So I'm not sure how to respond to comments that it's sensitive in Singapore. All right, so I'll finish up by saying this. Again, we care about segregation because we know that it has quantifiably important impact on socio-economic markers, such as labor market outcomes, schooling, employment, and so on, that kind of stuff. And we think that our study speaks to the distinction between residential versus real-time segregation. Right? Segregation comes in two forms. It's either residential or the kind that is more fluid, which happens in real time with your social interactions. So the traditional studies have looked at mostly residential segregation using residential census records. Right? So with the rise of geospatial data availability, people have been starting to look into issues such as the real-time experience segregation, which studies have found to be the main driver of segregation, not residential one. So in further studies, we plan to use maybe unsupervised machine learning algorithms to retrieve clusters of social exposure zones. And then we could possibly compare that with the residential kind of segregation measures. And to round off, right, so I first learned about city data in last year's Singapore Geo Festival 2020. That's how I found out about the data availability, and then I reached out to them, and then I got this data, and that's how this project got started. And so 2021, I presented it here. So I guess we've come full circle. Right. Okay, thanks. I'll end here. Thank you.
Thank you, Lucas. That's wonderful to know. So glad to see the two partners collaborating for this year. So Lucas, I think you've answered the question that's going to pose to you, but if you can expand a little bit more, how was the use of geospatial data crucial for your study? And with this data, what is the key steps forward?
The use of geospatial data was crucial because the unit of analysis is a geospatial unit, essentially. And then we matched it to all kinds. We pulled from various sources of data from all over the place to create a novel data set, which we can use to study. But most of the data that we used do not originally have the correct geospatial information. For example, if we use transaction records, addresses in words are not the correct geospatial data that we want. So we need to do some kind of processing. And even if the data comes in the correct geospatial kind of format, like shape files or point data, it's at a different level of aggregation. And so we had to do some kind of processing. So for example, to match weather records to neighborhoods, we had to retrieve the geolocations, the geo coordinates of the weather stations, and then we map neighborhoods to the nearest recorded rainfall. And that kind of pipeline requires some kind of GIS process in it. And then there are other examples where home addresses, business addresses is another example, where we had the addresses in words, which is unstructured and it's not what we want. And and so what we needed to do was we need to change the addresses in words to the correct geo coordinates in latitude and longitude, and then we could do the point in polygon queries to determine which addresses map to which neighborhoods, that kind of stuff. And we also needed to control for example, inter-neighborhood distances, which was crucial for our study because we don't want to be capturing logistical choices in that you are visiting neighborhoods that are near because, sorry, I can hear other sounds. Is it my mic or is it somebody else's mic? Oh, okay. Sorry. Yeah, so we needed to do feature engineering or geospatial feature engineering to recover inter-neighborhood distances, and that allows us to disentangle what are the drivers of neighborhood visits. We don't want to be capturing effects such as visiting neighborhoods because they are near to your neighborhood of origin. Right? And of course, most importantly, the main component will be the origin destination flow of movement for individual mobile phone users, and that came from citydata.ai. And that's completely geospatial in nature. Yeah, thanks.
Thank you very much, Lucas, for the insightful presentation. Next, we have Apu Kumar from Citydata. Citydata is a mobility intelligence company based in San Francisco and also a GeoWorks geotech. So they're based at the PSA building, and you are welcome to visit them whenever you are around the area. And their data, APIs, and visualization apps reveal the influence and impact of the real-world physical environment on the behaviors, actions, choices, and preference of populations. Apu will speak about geospatial AI, civic innovation, and GovTech. Over to you, Apu.
Thank you so much, Vanessa. Thanks for the introduction. It's so good to see the SgGeoFest community and the geotechs all collaborating with each other in such wonderful ways. I'm glad you found us at last year's GeoFest, Lucas, and really happy that we were able to collaborate with you and work with you on this paper that you published. Amazing level of detail, super impressive. And before I jump into slides and content, yes, this typically tends to be a sensitive topic. And yes, there always is some bias in the data sets that are used for this type of research. We do everything we can to reduce that bias. And I can go into details as we get into Q&A about how bias can be reduced and how data can be collected to more generally represent the population of any city or planning area or county or province. So happy to discuss that in more detail. So having said that, I'm going to go ahead and share my slides. Much of what I'm going to be showing you today is at a higher level than what Lucas was presenting. So I'm just going to give you a sense for how this data comes about and what was the type of data that we shared with Lucas for this research, and a little bit about our company as well. So Vanessa, are these slides coming through?
Yes.
Wonderful. So Citydata primarily tries to answer the question, how many people? And what we have noticed and all the work that we've done in cities around the world is that most cities cannot quantify their population trends or their movement trends. And there are many different types of data sets that are typically used. So there's satellite data, satellite feeds. There might be sensors, IoT sensors, cameras, drones, and then there is the traditional on-site click counting manual surveys. So there are many different ways of collecting data about people presence and people movement in cities. But really, most cities don't know the answer to what are the trends, how many people, and what are their movement patterns. And that was the genesis of City Data, of our company. So we are a mobility intelligence company, and we focus on trying to answer the question, how many people, what are their movement patterns, and then more importantly, what is the real impact to citizens. Happy to share that we've been awarded a bunch of really cool awards over the past few months. We are a GovTech company, and that means we provide data solutions and data sets to government agencies, government clients, to nonprofits, to universities, academics, NGOs. And we recently also won the Smart 50 award for some of the work we did with specific work we did with cities in the US. Our solution to the problem of trying to understand how many people is to basically crowdsource mobility data, crowdsource data on an hourly basis, on a daily basis. And we do this using sensors, where we have access to IoT sensor grids. We work with mobile app developers and publishers, where we have access to those types of networks. We work with Wi-Fi hotspot operators. We work with Bluetooth beacon operators. So we are basically trying to crowdsource as much data as we can. Any data set that fundamentally gives us a sense for how many people, anonymized, of course, is a data set that we would be interested in. And so we built this awesome network of data sources in 1,580 cities worldwide. And we have built these mobility replicas for these cities. And then we provide the data sets and the replicas back to government agencies, mobility operators, and enterprise businesses. Our platform is called City Dash. This is the dashboard that cities and all of our clients basically get access to. It's very simple to sign up and get started. It is online. You can access it through your browser. All you got to do is link your LinkedIn account or your Microsoft account. Once you're into the system, you get access to this big table of cities. These are our global cities, and you just select your city and off you go. So you could select Singapore, you could select KL, Jakarta, Bangkok, New Delhi. In this case, I've selected San Francisco because they were one of our early customers, and they still are one of our largest clients. So in this case, I've selected the city of San Francisco, and you can click on any part of the map to get a sense for how many people in that specific neighborhood or in that specific census block group, CBG. You get people counts, you get a sense for the actual heat map for that area. The heat map represents where exactly were the people in those places without actually revealing anything about individuals. And then you can also zoom in to get a better sense for how people may have moved through parks. In this case, you're looking at Golden Gate Park, the green area, the largest public park in San Francisco. And the bright red colors show you the movement of devices, which are people, vehicles, bikes, e-scooters, all sorts of stuff moving through the park. You can also then start to combine such mobility data, which is coming into our cloud in near real time. You can start to combine it with other types of ground truth data sets, because while we have excellent coverage using our crowdsourced data in most of the cities, we are still a sample. We represent a percentage of the population. So you want to combine this with some way of measuring ground truth. And this could be data coming in from a sensor that you may have installed in the park, or a traffic counter at the intersection, street intersection, or some other measurements that you may have taken over time. Use that with our data sets, combine them and build your models to more accurately represent what really happened in that part of your city. So there are some very unique ways of using machine learning by applying that to our data sets and building very meaningful models. And then, of course, once you know where were the people and what were the heat maps and how many people, you want to know where did they come from. That's the next logical question. And so we provide these movement patterns between these census block areas, between the planning areas, between every zone in your city, back to the place of interest. And so these movement patterns or these movement vectors are super helpful for cities. And one of the ways they use it is to study equity zones, which brings us to the matter of segregation and equity in our cities today. So here is a very specific example going back to San Francisco and Golden Gate Park. One of the things that happened with Golden Gate Park in San Francisco is during the pandemic, which were many months of 2020 and a few months of 2021, they decided to shut down some of the main streets and roads that go through the park. So San Francisco calls this the slow streets program, where vehicular traffic was essentially shut off. And these streets were then opened up to the public so that they could walk and bike and enjoy the park more. No cars, no trucks, no buses. And so people really enjoyed this new program for the past almost 12, 14 months. And then as the economy started to recover, the city had to think about, should we open up these slow streets and bring them back to the way they were? And then came the question about, well, how did this program impact the people of San Francisco in the first place? Did everyone participate in the slow streets program and benefit from it equally? Or did some parts of the city, which are marked as equity zones, which are shown here in the bright pink shapes, did those zones benefit less? Did the other zones benefit more? Now, these are deep questions, and there is no easy way to answer these questions because really no one at the city was measuring anything for the past 12, 14, 18 months. But then they came to us and they asked us for our data sets, and we were able to show them the movements that had occurred from Golden Gate Park to the equity zones and vice versa over the past 24 months, and look at the patterns before the pandemic, during the pandemic, and as they started to recover and reopen. And then even go deeper to show exact movements from the park to different areas within each of these equity zones. And so using mobility data, using mobility intelligence, cities like San Francisco are able to go very deep to understand the impact of the decisions they've made in the past, as well as make better data-driven decisions for the future by taking into account equity zones, segregation, and all of these socioeconomic factors that typically are hard to get to wrap your brains around. Along the same lines, you can track economic activity in any part of your city. So if you want to measure the visits and the footfalls to trade areas, commercial zones, coffee shops, and malls, you can do so very easily with mobility data sets like companies like City Data provide by combining it with POI data sets. You can take that a step further. You can try to look at building occupancy rates by overlapping the heat maps with building footprints. And again, look at this from an equity angle, as in how does this vary in different parts of the city? And is the occupancy rate lower in the equity zones versus the other zones in the city? You can also look at crime and have an equity angle to it, because crime rates vary by zip code, by postal code, by zones, by supervisor districts. And so in San Francisco, we are able to, and in many other cities in the US, we are able to overlay the crime categories and the crime counts by category and measure the impact for each of these zones using geospatial analysis. And off late with the proliferation of 5G, a lot of the telcos are trying to grow their 5G networks and transform the legacy networks. And we believe that there are ways of doing this so that you bring the network to where the people are, as opposed to just grow your network based on where the network is. And I believe there is a strong equity angle to this as well, because you can bring the network to low-income areas and find ways to have people benefit from your 5G new 5G small cells by putting them in areas where the people really are looking at mobility data and looking at density heat maps. You want to do a lot of this in the present, in the future, but you also need to do a lot of this with a historical outlook. And so you can do historical analysis going back in time using platforms like ours. And we take great pride in that because we let our clients go back in time and do digital mobility surveys all the way back to 2018, 2019, 2020. So you can do month over month and year over year analysis. And last but not the least, we are very active in Southeast Asia. And so our platform and our data sets and our insights must be localized and are localized in all the major languages so that all of our clients can benefit from it. Data and privacy go hand in glove. We've taken great care to understand the implications of crowdsourcing data sets and how this works with privacy regulations. In the EU, we have GDPR. In the US, we have CCPA and more coming soon. In Singapore and Southeast Asia, of course, there's PDPA. So we take great care to anonymize, obfuscate, aggregate our data sets so that when we provide them to researchers like Lucas or to government entities, we are giving them a privacy compliant, ready to use, high integrity data set. So with that said, I will conclude this talk and I'm happy to answer more questions about these data sets. And I'll hand it back to you, Vanessa. Thanks so much.
Thank you very much, Apu. One question for you. What are the challenges for geospatial startups working with local governments?
Oh, sure. So if you think of government agencies and geospatial data, I'm sorry, is there a beep? Oh, here you go. So if you think about government agencies and the way they've been using geospatial data, the COVID pandemic was a disruptive event, and it forced a lot of these local government agencies, at least, to take geospatial data more seriously. So simple things like dashboards and location-powered mobile apps started to gain momentum, to share timely information with citizens. This created new opportunities for startups to collaborate with local agencies and federal agencies. But I think many of the traditional challenges were still in place and are still in place. And one of the biggest ones is procurement. So procurement tends to be a major hurdle with any type of engagement, let alone geospatial data. And very few government agencies, in my experience, are able to readily adopt SaaS products and data products. Their internal invoicing, their billing systems are not set up to handle subscription products. And even fewer government agencies can handle or purchase data-related solutions or AI-related services. So we see these as being hurdles when we work with local governments, because these do not fit their standard definitions. We've also seen issues with the much dreaded RFP process, or the bidding process, which takes 6, 9, 12 months for a government agency to complete the analysis and announce a winning bid, and then starts procurement. So in my humble opinion, I think these are all obstacles to innovation. And I sincerely hope that agencies around the world, government agencies around the world, will take notice, modernize these procurement systems, and keep up with the latest trends.
Thank you very much, Apu. Next up is Heroin Boss from TNO. TNO is also GeoWorks Geotech and based in Singapore as well, at PSA building. And Jeroen will talk about on the social inclusion aspect and the impact of urban redesign and infrastructure investments. Over to you, Jeroen.
Yeah, thank you so much. And I will put up my slides. Indeed, what I will talk about is, well, how we can use digital city twins and modeling in order to understand what the impact of investments, spatial investments, investments in infrastructure will have on different target groups and how they distribute in space, and in that sense contribute or go against segregation. But first, before I do that, I will say something about well, what we are doing, how we look at cities especially. What we see is that, well, cities, city governments want to design their public space in order to, well, optimize livability, but also accessibility, sustainability, wealth, a good living environment, well, for all. So you could say equality or equity. And that while space in urban areas, in densely populated areas, is scarce, and people who live in Singapore will recognize that, right? And at the same time, we see a change in, well, mobility, in logistics, in ways how we can meet each other and how we can deliver goods. And the main trends that we see are digitalization, the whole platform and sharing economy, automation, higher levels of automated driving, and electrification, or you could say the climate goals. And then one of the questions is not only how does, for instance, investments in infrastructure affect something like modal shift? Will more people take the train or take the bus instead of the car? But also, who are these people and how do the economic effects distribute in space? And what I'm about to share is more about the ambition that we have, that we work towards. So what we have as a platform, and I will go through it quickly because I presented in an earlier panel already, is Urban Strategy. It's the software that we use to build our digital city twins. And what Urban Strategy does is combine data, data sets, large data sets, as we have seen presented by Apu, these can be quite large in volume, and you need ways to handle these big data sets to keep them accessible for your models, which is a different component, another component on our platform. Simulation models that we have made way much faster than the current state of the art. Using a GPU, for instance, high performance computing, so we can make these complex models accessible, make them work in a setting where you have decision makers literally standing around the table and work with interfaces to look what is happening in their city, literally. And we have built these digital city twins, well, in several places, of course in the Netherlands, in Europe, but also in Singapore, in Portland, and on the island of Curacao. And what we do with these digital city twins is, well, as said, look at what is happening in the city from different angles, look at what is happening with mobility, how is the mobility demand distributed in space, how is the network allocation or the assignment, how will public transport or the road network be used, what are the environmental effects, and we don't only look at emissions but also at concentrations and exposure. So you can also look at where are people most affected by the negative impacts of well, mobility or industry. And we also look at the different models that describe how energy is being used in space and time, and that's important when you look at electrification strategies, but also how well, different areas get access to new energy carriers, so to say. Also, and in the end, also the energy transition has an equity component to it. We applied this, as said, this digital twin in different places in the world. One of the big examples is Amsterdam, for instance. And in Amsterdam, well, we have this digital city twin up and running, and we can see right now if you do a change in well, either a transportation network or in a model you add new buildings or offices or hotels, whatever, we can see how traffic flows change. So how the traffic flows shift from one modality like car to, for instance, a train or metro, or how people will use active transport like walking and cycling more or less given the scenario. But then the next question that arises is, who are these people? Are the higher incomes or the lower incomes? In other words, if we do an investment, for who do we do it? Is it for the people who have already opportunities actually, and we even extend that further, or do we help the people who have less opportunities to access jobs, for instance? And in order to understand that, we bring together multiple components, and what we are building in TNO is what we call an activity-based model. So we do not only describe how many people travel in which mode and when, but also to which activity it is linked, and what the population characteristics are linked to every trip that we can see in our data or in our model. And that way we can train the models not on the travel patterns, but on the activity patterns that lie underneath. And that gives a better understanding if we change something in the simulation, how people will respond. And that seemed, or that appeared to be very helpful in the COVID crisis, because the models that were trained only on the mobility patterns did no longer suffice to understand how we saw mobility patterns change. So we needed those kind of activity-based models where trips are linked to economic activities. And then, well, the next step, and then I get closer to this, call it segregation or equity, is where you see in the Netherlands as a whole, and for these maps, this is not our own work, it's a collaboration with the Free University of Amsterdam. They analyzed how highly educated people are distributed in space in the Netherlands. And there you can see they are, you could say, more clustered around the more densely populated areas. They live more in cities than the, you could say, the low educated people are. They are distributed differently throughout the country. And if you analyze trip data, you also see something, that the commute times or the commute distances that high incomes, highly educated people have, especially when it comes to public transport, are much longer, and especially between the poles in our Randstad. It's the densely populated area on the west part of our country, and you see that the low educated part of the community has a much shorter commute distance. And this is important to understand if you look at the impact of new infrastructure. And to give an example of what our colleagues from the Free University analyzed, is what the impact of rail tunnels north of the Dutch capital were. And if you look at the modeled impact of what happened, it's sometimes at first of what decision makers intended or thought that would happen. Because what you see is that the number of jobs in the north of the Netherlands basically declined because of these tunnels. What you see is that the jobs, the economic activity moved towards the place where there already was a lot of economic activity, our capital, south of the big canals cross-cutting north part of the Netherlands. Another effect that you see is that the property value in the same area where the amount of jobs declined increased. And you also see that the amount of highly educated people in the north of the Netherlands increased. So you can say for these tunnels, this new infrastructure worked very well for the highly educated people with already opportunities. Now they got access to a nice, less dense part of the Netherlands where they can live. But what the effect is that they raised the property value, so the house prices, and the people with less opportunities, with lower incomes, have no access or less access to the jobs that moved to our capital, but they saw the house prices in their area increase. So, well, this is an effect, I think, not intended by an investment in infrastructure. And we say it's a very important next step in our modeling. That's why we now cooperate with the Free University of Amsterdam to get these type of economic equilibrium models attached to the transportation models that we already have in our digital twins. And that is important because, as I showed on the first slide, there is a lot changing in mobility. Automation in the far future, maybe investments like Hyperloop or other ways for transportation. But what we saw in this even simple example of a rail tunnel, we have to be aware how the positive or negative effects of these new types of transportation are distributed in space, in time, but also amongst different target groups. And well, using geospatial data, we can provide that insight and make sure that big decisions, infrastructural decisions, investments are better informed. So that's what I would like to present, and I hand it over to you, Vanessa. Thank you.
Thank you, Jeroen. A question: what are factors that influence transportation poverty, and how can we use geospatial and mobility data to detect potential transportation poverty? Maybe as an extension of what you've already spoken about just now.
Yeah, exactly. So one of the factors is to analyze what type of transportation and what type of access different target groups already have, and analyze where workplaces are, where they have to go to in order to get job opportunities, for instance. And when we zoom into the city of Amsterdam, we see that very clearly. There are now plans to extend a metro line. But when you look closely, this metro line, without having done the analysis thoroughly, I must say, but one of our hypotheses is that it will contribute to highly educated people getting better access to the central business district, while people living one district further with lower incomes, only get, because such a metro line will also influence how bus routes are being planned. It will affect the bus routes. And if you look at that whole picture, you will see that the districts with higher incomes get better accessibility to their jobs. And actually, areas with lower incomes will have limited accessibility. So something that sounds like a good investment you get a model shift from car to metro, will end up with an increase of less accessibility for people who already have less chances on the job market.
Thank you. So moving on from Netherlands to Singapore. So Lucas, based on what Heroin has shared just now, do you see any similarities of the situation in Singapore as well? And how is it being managed?
I guess the transportation patterns would be quite different. I think Singapore is much smaller than Amsterdam. And I guess here the situation is reversed in that it is the poorer people who use public transportation rather than the wealthier people. Yeah. I don't really understand much about Amsterdam transportation system to say much actually, nor the transportation system here. Yeah, but I agree that the placements of the railway tracks would influence where the bus routes would be. And that's one important factor.
Apu, do you have any further comments on this?
No, I agree with what Jeroen and Lucas have shared so far.
So Apu,
Is it something that you see? Oh, sorry.
Yes,
I
go
have a
on,
question
please.
to Apu.
Yes.
Is it something that you see in the US as well, that sometimes these investments lead to mobility poverty and have the adverse effect of what was thought in the beginning?
Yes, we've seen some examples of it. So to go back to one of these specific use cases that we were looking at in San Francisco with the Slow Streets program, one of the observations, there are some results we share, there are some results we don't openly share based on what the cities ask us to do. But there are some observations where sure enough, all of the citizens were able to enjoy the parks more as soon as you blocked vehicular traffic from entering the large parks. And that kind of makes sense because now you can roam about freely. You have less concern for accidents, and you have more bicyclists and pedestrians in your open spaces. But one of the effects that they found that they were not expecting is that because the equity zones, the people in the equity zones, used more public transportation, and since the buses now had to go around these blocked streets, it made, in some instances, just day-to-day chores more complex for the people in the equity zones in the low-income areas. And this was something that they had not anticipated. And so, yes, sure enough, you see advantages, and then you see these side effects of these programs. So you see both of them.
Thank you. A question for Lucas. In what ways have social scientists benefit from the availability of geospatial intelligence? And to the audience, if you have any questions, please feel free to place your questions in the Q&A box. Lucas?
Yep. All right. I'll be quick with this one. For one example, there are a few main threads of literature where social scientists have used geospatial data. So the study that I presented was one of those threads which looked at experienced or real-time segregation instead of the more traditional residential segregation. Then there are a bunch of other studies that combine urban type of data with labor market issues or urban data with crime, like Apu mentioned. And I like one study that I found recently, which is where they find that the presence of policing patrols do not deter crime. What it does is that it geographically displaces crime. And then I think that's interesting, and that's something that you could only have done with geospatial data, for example. And then with the COVID-19, there's a whole bunch of literature, I think in the past year, that's geospatial related somehow, a lot of them. Yeah. And one main theme that comes out of those literature is that social distancing is a social privilege. It's the wealthier people who gets to practice social distancing. And I think that fits into the main theme with what Apu and Jeroen has mentioned, with differences between the classes, the usage of public transportation infrastructure, all those kind of stuff. Yep. Thank you.
Out of curiosity, Lucas, so when you first started in the work that you do, how was it defined for you? Were you actually coming in from a geospatial angle from the start, or did you just somehow grow along the way and figured out you have to have different data sets, different tools, different platforms, and so on?
Yeah, I didn't have this in mind until I saw what city data had. And then I formulated that, or I could link that to socioeconomic status. And that's right, I wasn't trained in geospatial or urban kind of stuff. So I still don't know how to use ArcGIS, for example. So I use the open source tools like GeoPandas and PySal. And I had to pick things up along the way. Yep.
Great. And GeoWorks, the community, we have tons of events and programs as well. So anyone is feel free to check it out also at our website. So a question for you, Apu. Are government clients seeking access to geospatial platforms? Are they staffed with adequate in-house talents and skills? What's your sensing at the moment, based on your experience?
The answer is no, but the answer is also it really depends. It depends on the size of the city. It depends on the budget of the city or the municipality. So larger cities like San Francisco, San Jose, Houston, top 20 cities in the US, for example, they all have in-house data science teams. They have chief data officers. They have elaborate processes in place for handling data and making data-driven decisions. But then if you look at the other 95% of cities, or even 80% of cities with populations of 250,000 people or less, what do you do with them, and are they adequately budgeted to hire data engineers, chief data officers? They might have a license or two for geospatial platforms, off-the-shelf platforms. They might have some visualization tools, but they certainly may not have the in-house geospatial skills or the experience to really use those tools to the fullest extent. And that is why the work that we do and the work that TNO does, it's really to help these cities and help these agencies to fully understand the extent to which geospatial data analysis and insights can help them make smarter, wiser decisions. So yeah, the short answer is no, but it depends on the size of the city. It depends on the maturity of the data operation within the city, and of course, at the end of the day, the budget that the city holds.
Thank you, Apu. We have a question here. Let me just show it on stage. Does anyone want to take this question?
No, I have not heard of this. Maybe this guy, Emmanuel, wants to share more about what is this tool, or I don't know.
Emmanuel, if you'd like to share in the chat box.
I think this might be about building decentralized social applications. I just have a very peripheral understanding of Solid, so certainly not enough to answer the question. But I think this is about privacy and decentralization.
Right. With that, thank you so much for this engaging and insightful sharing. And thank you also, gentlemen, for your good work in this area. I'm sure we'll go into new areas in this space. And we hope the audience can get some key takeaways here today. And who knows, perhaps we'll see you next year sharing at SgGeoFest as well. Thank you and have a good Friday.
Thank you, Vanessa.
Thank you.
Bye now.
Bye-bye.